Let's go ahead and practice substitution and elimination and solve and then check our answers by graphing with Desmos. So in the first problem, negative 4x plus 2y equals 12, y equals 4x plus 3. We'll notice the second equation is solved for y. And in that case, that means we are going to need to use substitution. That would be probably the best technique. And so we look at what's after the y equals, or x equals, in this case y equals, since it's solved for y. We'll circle that, we'll draw an arrow up to the first equation. We're going to trade that out for the y value in the first equation, and then we are going to rewrite that first equation. Negative 4x plus 2, instead of 2y, we make that substitution of the 4x plus 3 equals 12. So we rewrite that first equation, and now it's just a matter of algebraic steps. Do you remember how to do your algebra to solve here? Now this is a little bit more complicated equation. There's a few things that we need to do to simplify it before we start undoing from both sides. First thing is we notice there's a number in front of the parentheses. So I might just write over here distributive property. I'm going to abbreviate. Dist_prop means distributive property. So we're going to simplify that. And so that gives us negative 4x plus, okay, 2 times 4x is 8x. 2 times 3 is 6. And then we notice we have a couple like terms that are on the same side of the equation. A couple terms that have x's, which means we can combine those together. So combine like terms. These two go together. Negative 4x plus 8x would be a positive 4x plus 6 is equal to 12. All right, now we go ahead and solve by undoing from both sides of the equation. So now we subtract 6 from both sides of the equation to undo the 6 and eventually start to get x by itself to solve for x. 12 minus 6 is 6. And then we can divide by 4 to undo the multiplication here. We'll divide both sides by 4, and we get x is equal to 6 divided by 4 would be 1.5. So remember, that is half of our solution. It's the x value for our solution. So now you got to go back up and say, okay, well, which one of the equations would it be easier to plug it back into, to substitute it back into that 1.5 and get the y value? In this case, the second equation, you can substitute it into either one, but that second equation is going to be a little bit easier because it's already got y by itself. So if I just rewrite this down here and think about, okay, we're going to put 1.5 in for x. 4 times 1.5 plus 3. All right, so that would be the same as 6 plus 3. Just type this in on the calculator, which is equal to 9. So our solution seems to be 1.59. And we can go ahead and confirm that by using Desmos, as it says. And you guys should be doing this pretty much every single time, because no matter what, even if you forget the algebra, even if you're confused on the algebra, you can always check your answer by going to Desmos, typing in the two equations, and then seeing where they cross. And where they cross, that intersection point is the point that works for both of the equations. It's the point that's on both of the lines. So in this case, there it is, 1.59. So we can confirm that our algebra has been done correctly. We do have the correct solution. Let's do another one. Now in this one, we're going to go ahead and do the elimination method. Since I see the coefficients 6y, 6y, that means that I can eliminate the variables by subtracting. I can eliminate the y variable specifically by subtracting. And so then I need to subtract across, do everything. So I need to subtract the 15x minus the 4x would be 11x. 6y minus 6y would be 0. That's that elimination. And then careful on this one, 27 minus negative 6 is the same as 27 plus positive 6, which is 33. So that gives us 11x is equal to 33. Don't really need that plus 0 there. And then dividing both sides by 11 to undo the multiplication, I get x is equal to 3. So you notice you kind of get that first half of the solution pretty quickly in the elimination method. But once again, that's only half of the solution. So now we got to plug it back into one of the equations and solve for the y. You can plug it back into either equation. It's really whichever one you think is easier. I generally like the ones that are more positive. So I'm going to choose that first one, even though it's got slightly bigger numbers. So the 15x plus 6y equals 27. And I'm going to take that x value of 3 and plug that in. So 15 times 3 plus 6y equals 27. I need to do a little simplifying here. So 15 times 3 is 45 plus 6y equals 27. Now I'm going to start undoing from both sides. So subtracting 45 from both sides, that leaves 6y is equal to negative 18. 27 minus 45. And then undo the multiplication by dividing both sides by 6, and you get y is equal to negative 3. So our solution is x value of 3, y value of negative 3. Let's go ahead and check that solution. Type in both equations. 15x plus 6y equals 27. Oop, that didn't turn out. Let's try that again. Plus 6y equals 27. And then 4x plus 6y equals negative 6. Let's try that again. Negative 6. There we go. Check the intersection. There is 3, negative 3. Good. All right, C. This is one of those problems where you don't have the same coefficients and we don't have one of the equations solved for y. So remember what we talked about on the first page with this one. What we're going to do is we're going to solve it for y first. So we're going to take that second equation and solve it for y to get us 6 minus 2x, y equals 6 minus 2x. And now I'm going to go ahead and do my substitution. So y equals 6 minus 2x. I'm going to put that into the first equation for y. Let's make that substitution. Let's go ahead and rewrite that first equation then. 4x plus 3 times the substitution of 6 minus 2x equals 5. All right, so now we go through those same solving steps that we had talked about back up here in the first problem. So we'll do the distributive property. 4x plus, 3 times 6 is 18. 3 times negative 2x is a minus 6x equals 5. Combine our like terms together. In this case, the 4x plus the negative 6x, we can put those together since they're on the same side of the equation. So that would be 4x plus negative 6x would be a negative 2x plus 18 equals 5. And now let's go ahead and subtract 18 from both sides. Negative 2x equals negative 13. And then dividing both sides by negative 2, I get x is equal to positive 6.5. All right, so that's half of our solution. Remember, we got to plug that back in to figure out the second half of our solution. In this case, I'll probably plug it back into this modified equation here because we're looking for the y value. And so now I can take that 6.5 and put it in for x. So y equals 6 minus 2 times 6.5. 2 times 6.5, so that'd be 13. 6 minus 13. And that turns out to be negative 7. Hopefully I've done all that math correct. let's go ahead and write down our solution, 6.5 and -7. And let's just double check that we did that correctly. All right, so 4x plus 3y equals 5. 2x plus y equals 6. 6.5 -7, which is what we had. So thankfully, that worked out. All right, last one on the page here. So it looks like in this case, once again, substitution is probably going to be the best technique. We talked about that on the first page. X equals in that first equation. So whenever you have an x equals or y equals, you can trade the one side equation out. So x equals, we're going to substitute that in for x and rewrite that equation. So 5y plus 2 plus 3y equals 26. Now, if you want to put parentheses around it, just like we've done before, you can. But since we don't have a number out in front, no coefficient to that x, the parentheses don't really apply here. They're not needed, which makes this maybe one step faster since we don't have a distributive property, but we do have some combining of like terms here. So that would be 5y plus 3y would be 8y plus 2 equals 26. Subtracting 2 from both sides, we get 8y is equal to 24. Dividing by 8, y is equal to 3. Okay? And then remember, that's half of our solution. Let's go figure out what the x value would be for the solution. We got to plug that back into one of the equations and then solve for x. I'm probably going to take this first equation since it's already solved for x. And so then we'll put our y value in. So 5 times 3 plus 2, which is 15 plus 2, which is 17. So our solution looks to be x value of 17, y value of 3. One more time, let's go ahead and check our answers on Desmos to see that we did that correctly. So x equals 5y plus 2. X plus 3y equals 26. (17(3). There we go. So on this page, we've checked all our answers on Desmos. We've had a couple different techniques that we have used.